Formula 1 is dominated by the challenge to produce a car which is stiff and strong enough to tolerate and resist impact, has maximum aerodynamic downforce, and is lightweight. Furthermore, all components must be able to survive the heat and toil of a 90-minute race. Therefore, it is not surprising that 80% of the components used to make Formula 1 cars are made from a form of polymer. A polymer is a molecule with a large molecular mass. It is made by linking together small repeating units, called monomers. The process of linking monomers together is referred to as polymerization. Here we see four monomers joining together via a covalent bond to form a polymer. There are two types of polymerization: step growth and chain growth. Chain growth polymers, also known as addition polymers, are made through the addition of alkene monomers to the reactive end of a growing chain. There are three possible types of reactive end group: free radical, anionic, and cationic. All three of these have the same common mechanistic features: initiation, propagation, and termination. Step growth polymers, also known as condensation polymers, are made by combining two reactive functional groups whilst removing a small molecule, such as water. The monomers used in this process have reactive functional groups at both ends of the molecule. Unlike addition polymerization, there is no initiation or termination step. All tyres are supplied by Pirelli for the 2015 season. Their composition is determined according to the known characteristics of the track. Tyres act as the only point of contact between the car and the track and have to withstand strong forces. Now let's take a look at the main structural components of the tyre.
Bead wire, developed with technologies that support higher angles of drift. Casing, made of composite materials and specific geometries that improve the stiffness values. Tread belt, the heart of the tyre, determines the support area and ensures performance grip.
The tyre is constructed from a blend of synthetic rubber, along with carbon black for reinforcement and abrasion resistance, silica for low heat buildup, and sulfur. The blend undergoes vulcanization, a chemical process making rubber more durable by forming sulfur crosslinks between the polymer chains. Cross-linking is when a molecule is added that can form covalent bonds with more than one polymer chain, linking them together and increasing strength. One of the polymers used in the blend is the polystyrene butadiene block copolymer, which is a type of synthetic rubber. A copolymer is a polymer containing two or more different monomers. Block copolymers arrange these into two separate groups. Here's an example of the mechanism for combining one styrene molecule with one butadiene molecule. The first step is initiation by a nucleophile. The nucleophile attacks one end of the double bond, then the double bond breaks to form the anionic reactive site. Although a nucleophilic attack is not expected, benzene acts as an electron withdrawing group, removing electron density from the double bond and allowing this to occur. The next step is propagation. Here the anion on the styrene molecule acts as a nucleophile, adding to the end of the double bond. This leads to the movement of the double bond to the next two carbons in the chain, and the breaking of the final double bond to form an anion at the end of the chain. This anion is then free to react in the same way until all the polymer in the beaker has been used up. Polyisoprene, natural rubber, and polybutadiene, a synthetic rubber, are the main elastomers. Elastomers allow the tyre to be stretched and deformed and recover to its original shape. Polybutadiene is used as it does not become brittle in cold temperatures. The main bodywork of the car is made from carbon fibre composite, as it is lightweight, very strong and stiff, and easily moulded to any shape. Kevlar is also used in the front wing end plate as it protects the driver and prevents massive damage to the car on impact. Kevlar is 5 times stronger than steel weight for weight and is also used in bulletproof vests. Carbon fibre is made from the polymer polyacrylonitrile, which is heated in a process called pyrolysis, producing a ladder polymer. It is then roasted slowly at around 400 to 600 degrees C to join the adjacent chains, causing the removal of hydrogen gas. Then it undergoes even more heating, this time at around 1300 degrees C, to form a carbon ribbon and nitrogen gas as a byproduct. The carbon fibres are then placed in a matrix, which is filled with another type of polymer, epoxy resin, and then set using even more heat. Kevlar is a type of polyamide which is a step-growth polymer. It has a strong rigid backbone due to the presence of aromatic rings. It also forms hydrogen bonds between the lone pair of electrons on the oxygen of one chain and the delta positive hydrogen of another chain. This allows the chains to pack very tightly together, giving its characteristic strength. Kevlar is made by reacting 1,4-diaminobenzene with terephthalic acid. Water is also formed as a byproduct. Another polymer that is being introduced into Formula 1 in the bid to increase safety is Xylon. Xylon is the trademark name for a range of thermoset liquid crystal polyoxazoles. Like Kevlar, Xylon also forms hydrogen bonds between the layers, allowing it to pack tightly together. However, due to the larger amount of aromatic structure, it is 1.6 times stronger than Kevlar. It is used in special anti-penetration panels in the driver's cockpit, as well as to affix wheels to the chassis, preventing the wheel from ejecting into the crowd in the event of an accident.